All right, in today's video, we're going to talk about different models of the atom throughout time. And this is really recent history that the atom has even been something that could be imagined. We now have a pretty good idea of what it would look like. You can't see an atom. So today, we'll just take a quick run through the different models. And when I say model, I'm not talking about this. No, we're not talking about that kind of model. And not those models either. So we're gonna move them off to the side a little bit here. The models we're talking about are ideas or visualizations of what the atom looks like if we could see it. Now again, an atom is so small, it's beyond our powers of perception. But we can do a lot of experiments to infer what the atom looked like, and that's what the early scientists did. In the atom, in addition, this model probably can't explain the universe, but the models of the atom can help us understand the universe. So let's get rid of these models and create some models of our own. Alright, so the first model was the brainchild, and a genius brainchild of this man. And he was, in his own right, a very well-known person in his day, and his name is Niels Bohr, and he is from Denmark. And we'll take a quick look at Denmark here. Here's Europe. Denmark is this northern part of Germany, just south of Sweden. So this is where he's from. And he was around in the early, and his idea came to be around in the early 1900s. Now, Niels Bohr was a very good soccer player. In fact, his whole family was athletic. His brother played on the Danish national team and was in the Olympics. But Niels decided, instead of using his head to head goals in, he used his head to wrap around the idea of what is this newly forming idea of the atom. And Bohr's idea of the atom, his vision, was this. He knew of the earlier findings of the quantization of energy, thanks to some of the early scientists such as Planck, and then the much earlier work of J.J. Thomson, where he discovered electrons. And he postulated that the atom looks like this. In fact, this is the vision of what the atom, this is what's stuck in the world today. Usually when you see like the Big Bang Theory, the TV show, their atom looks like this. This is the cover art, or I guess the opening credits art of the Big Bang Theory. And what you see hidden there behind the word big is Bohr's model of the atom. And it's really stuck in kind of the consciousness of the world. And it's very simple. He knew the nucleus was protons, and eventually they also discovered that neutrons resided here. And they also knew that there were energy levels now. Before, they didn't realize that energy was quantized, but as we saw in the previous video, that there were these levels, only certain places that the electrons can be, and so he called these electron orbits, and they run around the atom kind of as concentric circles, went around the nucleus in concentric circles, which means they have the same center, and they just are bigger and bigger and bigger, and you can imagine there'd be more and more and more. That's what we have here. Well, that was Bohr's theory. So the next vision of the atom, and what we currently hold as what the atom looks like, was postulated by several men. Two young physicists one from France, and his name is Louis de Broglie. Right here, you see him, and the other one is named Erwin Schrödinger. Again, these names not super important. But at the chemistry party, somebody might ask you, hey, do you know Schrödinger or Schrödinger's equation? Schrödinger had a famous cat, a thought experiment that you can look up. So Erwin Schrödinger. So two physicists came up with an idea that is easy to understand if you know anything about fireflies. So let's talk about fireflies for a second. So if we have a firefly, and the firefly is in a room. So this white screen is the room. And in the center of the room, I'm going to put a bottle an open container, a firefly sex attractant. So, the female firefly, the smell of the female firefly. And then we're going to turn off the lights in the room, right? And what we're going to do is we're going to set a camera up, and the camera's going to take a picture of where the firefly is every second. And so what you might expect, let's get rid of the picture of the firefly. What you might expect is something like this. Let's make the firefly red. So what you notice and what you'd expect is a cluster of firefly sightings near the center of the room, because that's where the firefly attractant is, and a few firefly sightings elsewhere in the room. Okay? Now what's interesting is, if you know where the firefly was at this second, you still have no way to predict where he'll be in the next second. Now you can make a guess and say probably he'll be somewhere in here. But he's a firefly. He could be anywhere in the room. And this is exactly the model of the atom. So let's take a look at what this firefly picture might look like in actuality. What we might end up with is something that looks like this, where in the center of the room, the concentration of light flashes would be the strongest. And so we would have a bright spot in the center of the room, and then as you move out towards the edges, it would get less and less bright because there'd be less and less flashes. And this is exactly what an atom looks like. Now this is what a hydrogen atom will look like. And the electron in this example would be the firefly. Electrons are the firefly. What do you think is the sex attractant? If you said the nucleus, you are right. And if you think about an electron, why would it be attracted? Why would it attract electrons? Well, it is positively charged, located in the center here, the cloud, and the electrons are negatively charged, and opposites attract. This model of the atom, or this vision of the atom, where there are no defined places for the electron to be, is what is known as the wave mechanical model of the atom. And so what we have when we talk about atoms now, instead of Bohr's model with defined energy levels, we have probabilities which take the place of those energy levels. So our first energy level will be here, this bright spot. It's likely that the electron will be located here. And as we build on this, as we add and the atoms get bigger and we add to this picture gets more complicated. But the big thing, two takeaways from this model: we never can know exactly where the electron can be, and the picture of the atom is based on probabilities. It's very probable that the electron will be here somewhere versus here, and so that part of the picture, or that part of the picture, will be the brightest. One last analogy, maybe to help you understand this: if you were to look at a fan when it's turned off, the fan blades would be very easy to see. You could say they're here, 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 and here. But what happens when you turn that fan blade on and it begins to move quickly? Much more quickly than your eye can see. Well, the blades get blurry and you get a cloud-like appearance. And that's exactly what, if we could see the atom, which we can't, but if we could, we would see it as a cloud. Not because it is a cloud, but because the electron is moving so fast that we're only able to see it as that kind of blurred motion. And it would be most likely to be nearest the nucleus, and so we would have our first energy level being close to the nucleus here.